Hello, welcome to another episode of Enlightning with my guest today, Matt Stratton. We're going to talk about infrastructure as code. Hello, Matt. Thank you so
Hey,
much for being a guest today. So happy to have you here.
I'm excited. It's way more
Good.
fun to be a guest than a host. It's a lot less work.
I'll have to take your word on it. But hint, anyone with the show, I'd like to be a guest sometime. So you and I met, we have kind of a funny origin story. I have nothing but wonderful things to say about the Kubernetes and cloud native community as someone who's like a woman and an older woman and a career changer who's come onto the scene and got to know people quickly and easily. But my first experience with you, Maddie, was karaoke at KubeCon in LA. Do you remember that?
I do. It was a week in the making, and everyone kept talking about what we were going to do and how we were going to get together, and it kind of snowballed into a whole bunch of people. And then we met at karaoke and probably bonded over mid '90s. Jams and Whitney's a high level of enthusiasm for said jams.
What I lack in talent, I make up for with enthusiasm.
Yeah. This is my whole career.
Lisa May says older woman. I suppose like not entry level. Yeah, I hear you. I'm young at heart. We all are. And so that blossomed into, it's a funny way to meet everyone because I met everyone that night at karaoke, but I didn't actually talk to anybody. So then I had a Twitter relationship with you, and that resulted in some puns. But in the end, you put out there, you're like, I want to do a KubeCon proposal, and you're like, does anyone have any ideas or anyone want to collaborate? And we didn't really know each other at all, but I responded to that.
I thought I asked you specifically. It might have been both. I don't remember either. Mm-hmm. But I remember a little leapfrogged about how we came up with the title for it and then had to back it off because we thought it might be questionable.
Which is I wish it was a Kubernetes baller. It was our original talk title.
That's the unofficial title of our talk, and it did show up in the talk eventually, but yeah.
So we ended up doing a KubeCon talk together about how to learn Kubernetes, or more about just strategies to learn when you need to learn a mountain of information. How do you get started? How do you make a strategy around that? I thought it was a pretty great talk. Oh, let me drop a link to the chat. To our talk.
While you're doing that, one of the things I thought the experience of doing the talk together reframed a lot of how I think about my public speaking, and I didn't really realize it until afterwards. And that reframing came apparent to me through arguing with people on Twitter, which is how I do most of my thinking. But I was talking about how, for various reasons, that talk was the best prepared I've ever been for a talk. And I don't mean I try to not be very much by the skin of my teeth, but there were a lot of factors that came into why we were really, I felt like we rehearsed way more than I normally rehearse. And one of those factors for people who are kind of don't have the background on that. Whitney and I had never given a talk before together in any way. This was going to be an in-person talk. Whitney lives in Texas. I live in Illinois. We couldn't practice together in person, and even virtually, it's not that the mechanics of handoff and everything when you're in person is different. And luckily for us, our talk was at the very end of the week, so we had the whole week when we were at KubeCon to be able to practice. And it really, as I was starting to get into a conversation with people about rehearsing talks, I sort of sussed out a bunch of stuff that we did because we never stood up on it. We didn't have a dress rehearsal. We just ran it a bunch, and it wasn't to memorize lines, but it helped us understand each other's flow. It was really interesting. That's a whole other topic, but it's changed a lot of how I think about talk prep, even for myself, through that experience. It was really interesting to me. Hopefully interesting to other people.
And so what lessons did you learn? And how are you going? I understand your daughter's about to give a presentation, your 10-year-old daughter.
Yes.
So how will those lessons translate to how you prep her?
So it's interesting because, again, it's different. And I made a couple jokes through her experience of this talk. So she's giving a talk. She's giving an Ignite talk at DevOps Days Minneapolis in the first week of August.
Cool.
And for people who don't know, because this will come relevant to how we're going to prep, Ignite is a really specific kind of talk. It's not just a lightning talk. It's not just a short talk. Ignites are 5-minute talks with 20 auto-advancing slides. And the slides auto-advance every 15 seconds. So compared to other talks, longer talks especially, you have to actually be really well rehearsed because you've got a short amount of time. The timing, the beats have to hit. Whereas if you're giving a 30-minute talk, your timing can kind of be all over. You can catch it up somewhere else. You can adjust. Trust me, I know. But in an Ignite, you're like, I have to do this. So you do a lot more prep in general. But then I was thinking, I'm like, I've looked at a few things because my daughter, she gives presentations. My kids in general, they give presentations in school, and they'll practice them for me. And it's funny how the feedback I give them is not what they're supposed to do because you're a conference speaker. What's the one thing you always say? Don't read the slides. Well, that's what you do in elementary school, right?
Yeah.
Your slides are your content, right? And that's fine, but we're going to work on that. But part of it is she can't. I mean, actually, she probably could. She's really good at this stuff. I don't want her to be in a position of trying to throw this together at the last minute. We want to be able to practice. So actually, this weekend. This is again, like a real conference speaker. Oh, I've got all kinds of time. And it's like, you really don't. Let's start working on this. 6 weeks seems like a lot of time, but going up north with her mom, there's tennis camp, there's a basketball camp, there's all this other stuff. I'm like, we really only have a couple weekends that we can work on this when you're not doing something else. But it is that rehearsing. It doesn't always, like I said, sorry, a lot of it is, and I think I'll look at the same thing with her, is that it's rehearsing to just be comfortable with the ideas so that you don't have to feel like you're on a script. But again, also, she's 10. This is also potentially kind of intimidating. She's going to be up there on a stage with hundreds and hundreds of people watching, plus however many people watching online. I think she's going to kill it. She's very precocious, very funny. She's very outgoing, but it could be scary. Okay, cool. Yeah, see, there's a question says, Java Grunt says, what's the title of her Ignite talk? I also have a 10-year-old. So I want to give the background story on this real quick, and then I'll explain. So the story, so for context, so my daughter, Sophia, so she's kind of obsessed with France and Paris. She really wants to go to Paris one day, and maybe we'll do that. So I was taking her to softball practice a couple months ago, and I said, hey, by the way, Soph, I got invited to give a talk in Paris, but I had to turn it down, and it was whatever reason. And she said, well, can I go instead? And I was like, sort of playing along, and I was like, I don't know, it's to give a talk. Could you give a talk? She says, I'm good at talking. And I said, well, you have to give a talk about DevOps. She goes, that's easy. DevOps, Red Hat, platypuses, it's fine. So I laughed. And so I just tweeted that because I thought it was hilarious. And people thought it was, got a lot of, I got my Twitter dopamine hit from it, but a lot of people were like joking. They're like, well, no, she should give that talk. That'd be amazing. And Bridget Crumhout, who runs DevOps Days Minneapolis, was like, well, you should propose it. And so she went through the CFP process. And again, like a good conference speaker, submitted her CFP the day it was due because we came up with this like 2 days before the CFP closed. So I was like, all right. She wrote the proposal by herself. I mean, I gave her ideas. She wrote her own bio. So if you go and look at the link that Whitney put in the chat, that talk description, that bio, Sophia wrote that herself. And honestly, I think it's going to be, I'm really looking forward to it. I think it's, and even in some of the, I don't want to give too much away. Well, there's not much to give away because we haven't done any of it yet, but we've been talking background, I've been sort of talking to her about like, okay, these are some of the ideas. And, to a 10-year-old, DevOps is just duh. Right? Like, why wouldn't you do things this way? And we do that all the time. And so it's a lot of framing through the eyes of a kid. And I think that's actually going to be really helpful for people to think about. If nothing else, she's very funny. It should be quite amusing. And it's going to be the last Ignite of the night. So hopefully she'll bring the house down. check out that link. It will be streamed live. It'll be recorded. DevOps Days Minneapolis has the best AV out of any DevOps Days because Joe Leahy, who is a professional AV person who also works on that event. So super excited about it. I don't know, maybe she'll come on Enlightning sometime.
Totally. Let's do it.
Yeah.
Java Grunt says good luck with that and looking forward to it. Java Grunt also mentioned they have a 10-year-old daughter. I want to say hello to everyone who said hello. We have Scale Zero, hi. Nick, the first one, always good to see you. Thank you for coming. We have a hi, Maddie and Whitney, hello. And then Bucky Robert, hi. So those of you in chat, as we're about to get down to business here and talk about infrastructure as code. So I would love to hear who is practicing infrastructure as code right now and what technologies are you using to do that? So will you pipe up in the chat and let us know where you're coming from? And then meanwhile, as I transition to get behind the lightboard, Maddie, I was hoping you could maybe give a little bit of the history of how infrastructure came to be and what problems it's solving. How's that sound?
Yeah, that would be fun.
Yeah? Cool.
Everybody, not everybody, but people know I do love me a good DevOps or cloud history lesson.
Good.
So when we think today we're in this place around infrastructure as code, really, if we sort of trace the family tree or whatever of how we got to where we are, and I always feel like part of the reason I want to explain, part of the reason I think it's actually kind of important, it can be important to know the history is because number one, those who ignore history are doomed to repeat it, which could be good or bad. But there's usually reasons we got to where we are, and it doesn't mean that we have to always keep doing things the same way. But we can think about things. Also, there might be some fun stories. So if we kind of go back to before we called it infrastructure as code, you still might hear people talk about configuration management. Config management. And that was sort of primarily thinking about in the pre-cloud world when we were thinking about operating systems, instances, servers. Maybe they were VMs, maybe they were actually physical boxes. You'd have this scenario where you had lots of servers that you had to configure and manage and figure out what you're going to do with them. And as someone who did that the hard way for many, many years, it sucked. But it wasn't super bad at first because you're like, I had maybe, 3 or 4 giant computers to configure, but then we started to want to have more, and especially in the world of VMs, doing anything by hand was a lot harder. So everything kind of started with this product called CF Engine. And this guy named Mark Burgess, who, in addition to being like one of the best looking dudes in config management, there's some historical picture of him kind of looking very Steve Jobs. He created CF Engine, which was really kind of the first applying consistent config to systems in that kind of way. Excuse me. And then that's also where really Mark kind of popularized this idea around promise theory when it came to promises, which if you're a software engineer, promises are a thing that makes sense to you because you know about them in a programming way. When we think about promise theory around configuration, it's again this idea that a system will become eventually consistent, will become eventually convergent, right? So along the way, so CF Engine was a thing. A bunch of people had its challenges, and then this cat named Luke Knies was like, well, maybe there's a better way to do this, right? CF Engine is very cool, but it's cumbersome. I'm finding it cumbersome. As usually, anytime anybody comes up with something, it's because the thing that exists, they hit a bunch of rough edges. So Luke somehow convinced his partner to let him quit his job and spend a year trying to create a new product. So that's awesome to be able to do that. So really kudos to Luke's partner. Oh, by the way, some of this I could be wrong. So if you're hearing it and you're like, no, that's not exactly what happened. I love pedantry. So let me know. But anyway, so Luke had created something that you may have heard of called Puppet. And Puppet was pretty revolutionary for what it was doing. It was, you were using a domain specific language that was to create a desired state. And it was really powerful because you could write Ruby behind the scenes to build modules, to do things and this was really, really kind of, if you look at the beginnings of DevOps, Puppet and this modern infrastructure, this modern config management was really important because we were building these bigger systems at scale. And we look at, if you go all the way back and you read the Continuous Delivery book by Dave Farley and Jess Humble, config management's a real key part of being able to do continuous delivery as that idea, because you can't be doing these things manually. So it was really revolutionary. Then kind of along the lines. Oh, Whitney has to restart. Okay, well, that's good because I'm just telling a story. Along those lines, this guy named Adam Jacob had a consulting company, and he was building. This was in very early .com, kind of reboom days, and he was building cloud systems, or building systems rather, for all these kind of much larger tech companies. And he was bumping his head against a lot of stuff with Puppet, a lot of challenges, and kind of went in and said, I think Puppet should work this way. The other kind of made some suggestions. The Puppet team was like, no, we like things the way they are. And he was like, fine, I'm going to go make my own thing. And that thing is called Chef. A fun little backstory on this is why is it called Chef? Besides the fact that it gave us a bunch of remarkably awesome food puns for years and years and years. The original name for Chef was going to be Marionette, like Puppet. Marionette's really hard to type and really long. And Adam said, you know what? I know this is going to be a command that people are going to have to type. Sysadmins especially are going to have to type over and over again, and they can be kind of lazy. So what's a really short word is Chef. That's why Chef is called Chef, besides all the amazing food puns. So the big thing with Chef is that it brought to light is you wrote it in pure Ruby. So it was a domain-specific language, but it was not really. It was Ruby right from the beginning. So you got to do all the things that a programming language let you do. So this, to me, was the very beginnings of infrastructure as code, because it was actual code versus a different language that you then had to learn and then have to work around. And along the way, we had some other great tools came along, like Ansible, which Ansible was really accessible. And that's one of the really powerful things with Ansible. It was really easy to get started. It also is what started to bring us down the road of YAML. So sorry. Another amazing config management tool was called Salt, which was super duper fast, and nobody but network people really liked it. That's unfair, but that was really its adoption. And then finally, you may have heard of a little thing. And this was sort of when things were changing from reasoning about configuring servers to now we're configuring cloud resources, things in the cloud, like, not just EC2 instances, but, DynamoDB, VPCs, all these cloud things. And that's really what Terraform. Okay, sorry about that. I don't know what just happened to me too. This is just a cursed stream, I guess. Anyway, Terraform, its big thing was around cloud resources, and I think Terraform really helped bring a lot of people to the cloud because it made it really easy. And kind of flash forward to today. There's some other great tools that are around. So the Amazon CDK is letting us use infrastructure as code towards Amazon resources. And then this little thing called Pulumi, which is where I work. And the big thing to me that I think is really exciting about Pulumi and what brought me to Pulumi is it's actual code, right? So in something like Terraform or some of the other tooling, you're writing a declarative state, you're sort of writing things out. Maybe they're in YAML or whatever, but it can get cumbersome because you don't have the things that a programming language gives you. Whereas if we look like this was all, to me, a lot of the stuff when I talk about Pulumi, I'm like, this is all the stuff I used to talk about with Chef, right? You have all the things that the programming language gives you. It's ecosystem, it's conditionals, it's loops, it's packages, all that fun stuff. And the thing is, are you back? You're back.
I'm back. That was stressful. It took restarting the camera and like my studio setup and not just restarting my computer. And believe it or not,
well, then I hit a point when in StreamYard, it was like spinning, and I was like, "Oh, don't tell me that my internet just went down." So, yes, and eventually consistent. This whole show is eventually consistent.
Yeah.
But yeah, so part of it, why does this matter? Is it's just a matter of just getting us to the infrastructure exists to serve our application, our services, our things that provide value to our organization and our company. And we want to be able, the closer that we can start to tie those things together, it helps us with velocity. It helps us with consistency. It also, to me, things like infracode and infrastructure as software and all of this blur the lines in such a wonderfully DevOpsy way around, because the core of DevOps is not everybody can do everything, because we can't and we shouldn't expect to. But the more that when I'm building a system, I understand the needs of the people who are operating that system, and the people who are operating the system understand how systems get built, and all these really permeable membranes. And infracode is a really dope way to sort of help drive that. So
I want to acknowledge some people in the chat. We got some. So when we asked what people are using or what they have used, we got lots of Terraform, but also ARM Bicep for infrastructure as code. I'm familiar with Terraform, but not the other acronym. And Scale Zero says, I've only tried infrastructure as code with CloudFormation. And also Matt, and we also have hello from Solid Boy. Really looking forward to seeing today's board. Yes. Excellent. And Napalm's here too. Hi, Napalm. We have lots of buddies. So can you give me, since I was unfortunately absent, can you give me the 10-second version of the problem that infrastructure as code is solving? Or maybe the chat, you can do it too.
Yeah, I would love to see what the chat says too. So actually, I would take a second. Let's see what the chat has, because I said it a little bit, but maybe not amazingly. But then also, oh no, Rundeck. Okay, see, here's the thing. Okay, so Deshaun, just to be clear, so Deshaun I can see in the YouTube says a lonely tier because Rundeck is awesome. I don't consider Rundeck, and Deshaun, correct me if I'm wrong, I don't consider Rundeck an infracode or a config management tool. It's an automation tool. And this is, again, let's be pedantic, right? But it's just in a slightly different space, but an incredibly complementary space. So Rundeck is just a really awesome way to automate work you would do, which is what we're doing with config management and infracode. But it's not, it's sort of like the tasky stuff. And to me, it's runbook automation. And sometimes our runbooks are how we build systems, but sometimes they're what they do. And if you don't know, so Rundeck was acquired by PagerDuty a little while ago. And the funny thing is, I remember shortly before that happened, so Damon Edwards is one of the founders and also one of the very early DevOpsy kind of people. And I remember talking to Damon about like how they could work together. And I think there's a lot of really awesome things about that. Bash is code. Deshaun says the code in Rundeck is all Bash. Bash is code. But again, like you said, reducing the Bash soup. Another one of my favorite, fun little favorite terms that Bridget Cromhout uses is the idea of MVB, which is minimum viable Bash. Bridget talks about writing minimum viable bash. Most of my bash is minimum viable bash. And that's what you should aspire to in your bash, in my way, is just enough to get it done, right? But back to, okay, what's the problem that it solves? Besides giving us lots of stuff to fight about and argue about and be big nerds about. And I'll touch base on the big nerdery thing in just a second. The problem it's solving is focusing. There's just twofold, right? One is, what are the things we can be doing to more provide value? We want to focus on the value that we're providing versus the everyday. And this is why any of these automation tools really matter, and also why there's a lot of folks sometimes get a little scared of automation tools, not scared of adopting them, but scared of that they're coming to take their jobs, right? You know, the robots are coming to take their jobs. And here's a couple things that come to mind when it comes to this. The first thing is, I've spent a long portion of my career over the last 8 or 9 years, both as a manager of a team that was adopting these things and then being on the vendor side. Automation is never a headcount reduction strategy. And if it is, then you're doing it wrong, right? It's a reallocation of resource towards value. And a fun little story, when I was doing like DevOps consulting and transformation stuff, even in the very early days, I would do a lot of discovery interviews in the company. I go into a company and I talk to the testers and the developers and the PMs and the ops people and the executives. And I asked the same question as part of my interview to everybody. I said, I have a magic IT wand. You get one wish. What's your wish? And at every company, the devs would have a different wish. You know, at company A, the devs would want this. Company B, they'd want that. Testers always wanted something different. It was all very dependent. Every ops team I ever talked to, consistently, they knew the wish. They didn't even pause. They knew it. And you know what it was? More people in ops. because ops is always understaffed. But it wasn't. But the thing is, the reason is so many ops teams traditionally, and this is getting better, but it's still true, are focused on so much like block and like the stuff that doesn't add value. So they have all this great value they can add, but they don't get to because they're spending all their time moving files around or building systems or doing all of this stuff. And so it's just refocusing, right? Way back in the day. So
what you're saying is, instead of automation making ops people lose their jobs, instead you're making it so developers can push code way more often. Well,
it makes it so the ops people can focus on other value they add, which is they really understand how to optimize and enhance and get the best out of these systems. And this is one of the things I would say is, if the only value you provide to your organization is you're really good at copying files around, then you probably should be worried. But that's not true of most ops folks. That is not the only value they add. The problem is, Napalm says that you're much quieter than I am. That could be a tech problem. That could also be a Maddie problem. So I could also try to.
If you could turn yours down, that will be.
Let me see what
I don't know how to control my stuff.
Yeah, I don't know. I could. Well, no, I was saying it could be I can just turn, maybe not technically. Oh, I can turn the gain down. Is that better now?
Yes, that makes you quieter.
Yes, I am saying that people can actually add value. Java Grunt says, "Are you saying that ops people can actually add value?" Yes, we can.
Yeah.
And that's but yeah, what we're doing is we're saying, okay, how do we, again, DevOps, all these things are how do we accelerate our ability to give value to our customers, right? And there's all sorts of skills that we have that we just don't always have a chance to use. This also
can I say that they're more fun to use? It's more fun to problem solve with new problems than to do operational toil where you're just keeping things at status quo.
One of my favorite quotes from the Continuous Delivery book, which is now well over, 12, 13 years old and still true today. And this is my quote around automation and why automation matters, is asking highly skilled people to do repetitive tasks that require a high level of technical skill introduces more possibility of error than sleep deprivation or inebriation, because that's the other problem, right? So when you're having people who are really skilled, and so that's the problem, is a lot of this sort of server janitor stuff, you actually couldn't just give it to anybody because you had to know what you were doing, but you were doing really tedious, repetitive stuff that didn't really require your brain, but you had to do it. And so we actually do it really poorly because we're like, God, I'm going to do this. I mean, trust me, I was that person for many years, right? It sucks. And so it's really empowering to be able to go to this. So, and again, it plays into how we deliver value, because there's just no way, again, to the point of, you can't do continuous delivery if you have to manually be building systems, especially at the scale we talk about now. But being able to, this all goes back to the it works on my machine problem, right? This is the other thing too, is so we can ensure that our systems, we can manage things like configuration drift, do things change? Because another thing I love about infrastructure as code / config manager, whatever, is sometimes we refer to it as executable documentation, right? Because I can look at the code that built systems, and then I know what those systems are like, versus the way we used to do it, which is it went into a wiki, and everybody knows all wikis are write only. First of all, they're write only. Nobody looks at them. Secondly, they are completely out of date within seconds of building. Another Mark Burgess quote, this is important too, is the minute that someone logs onto a system interactively, they compromise everybody's understanding of that system, right? So once you're in there, I now can't trust anything about it anymore. And so this also goes into our trust around things like audit, and just understand, whether it's for a compliance reason, we need to know what systems are like, or even just for troubleshooting and understanding it. Because again, as soon as I SSH into something, all bets are off. I mean, you can have as much logging as you want, but I can do stuff that doesn't get logged. And I don't mean maliciously. I mean, just whatever. Technically, I ran an LS. That changes the state of the system in a really weird way, but it does. So, yeah.
I want to acknowledge a couple chats. We have Cypheric says, hello, Whitney and Wiggity board folks. I like that. And Napalm said, it's worse than just bash inside YAML. Just saying. Ask me how I know. I have a feeling there's a story there. Please do feel free to tell it. So I'm kind of debating, like, as we're talking whether to capture it, I'd kind of like to maybe start with just getting a definition of infrastructure as code.
Sure.
Maybe it's a good place to start. What do you think?
Yeah. And definitions are always fun and very contentious and very fun. So we'll see what we come up with. Some of the things that I think matter to me, like for me to refer to something as infrastructure as code, it needs to be testable.
Okay.
It's a big thing, right? I want to be able to test it because that's the thing we do with code. It needs to be abstractable, and by that I mean whether, like it contain abstractions, right? So and which is the idea where I can say, again, all abstractions are fundamentally leaky and problematic, but like I need to be able to sort of have a component or something abstract that is just sort of this object that I don't have to reason about because it's trustable. So we'll talk about what those abstractions come in, and they're I think, that's so I see in the chat, so there's two things came up in the chat that I'm was debating in my head. So one is about it being repeatable. I think the other one was about it being in in a versionable. That's what it was. I was trying to think about the way I wanted to say it's versionable. And
source controlled versionable.
I would say actually just versionable actually is a little bit, because just being I can put my bash scripts in source control, but that doesn't mean they're versioned, right? I was the CloudFormation. So fun fact, I'm not necessarily here to sell, but it's amazing thing. So if you like the Amazon CDK, but you don't like CloudFormation, here's my little plug. There's something called the Pulumi interop for CDK, which lets you use CDK's resources, but the execution engine is Pulumi, so you don't actually have to use CloudFormation behind the scenes. So infrastructure being unbreakable infrastructure. So that's getting into this idea of immutable infrastructure, which is not necessarily a requirement for infracode, and sometimes it goes a little bit maybe against it. But that's sort of we've definitely gotten ourselves a little closer to this reality. So immutable infrastructure means we never go and try to fix something. So those are the three key things for infracode.
What about, you said before that infrastructure as code is executable documentation. So what do you think about one of those two words, executable or documentation?
To me, those are things that are features, like things you get from it, but are not requirements of it being like. To me, these things are, if you're going to talk about infrastructure as code, these three things have to be true about it for it to be infrastructure as code. Whereas it being executable documentation is an output of it. Also, you spelled infrastructure wrong.
Oh no!
But you've got room. You've got room. Infrastructure as code. Okay, now we're gonna. Yes, now we're gonna create a whole new space. This is a new space in the Gartner. There's a new Gartner Magic Quadrant, which is infrastructure as code.
I was just so engaged to what you're saying.
Yes.
Infrastructure. Okay. Thank you. We're getting live tweets from the guest. Okay. Executable documentation is awesome. Oh, Fuel Snabel's here with some PTSD stories. I love Fuel Snabel stories. Yeah. Today's word, CloudFormation. I don't know anything about CloudFormation. I'm going to look it up after this. So CloudFormation sounds like AWS infrastructure.
It is 100% AWS only.
Okay.
And it's benefit. I mean, again, everything exists for a reason, right? Like for the most part. Insert snarky tech you want to make fun of here. But and that's the other thing that I think is really important when we talk about all these solutions. There's not one right answer. And I used to say when I worked at Chef, I was a big part of the Chef community, loved Chef. That's why I went to go work at Chef. And even when I worked there, people would say, should I use Puppet or Chef? And my answer was yes. And I also like to say, like at Pulumi, and this has not just been true only at Pulumi, it was the same thing at Chef. I was like, our biggest competitor at Pulumi is Do Nothing Incorporated, right? There's so many people who are still doing things. Our biggest competitor is the AWS console or the Azure console. Get away from that, right? Yeah, there we go. I like this. Someone that says, I don't get why we ask developers to solve algorithms. We need CloudFormation copy pasters. That should go into most loops. Forget about a sort algo. It's like show just actually don't even have to show me. Just tell me a CloudFormation story, and then I know that you've been in it, right? Fun fact that actually goes a lot to my one of my old interview style questions when I was hiring ops people when I used to run ops teams is I would always ask people to tell me about when they broke production. Or I say, tell me your gnarliest story about when you accidentally broke production. And it did a couple different things. One is it showed a little bit, it's a risky question to answer. Some people will not want to answer it, but also that's sort of a way of just seeing like, yeah, you've actually done some stuff. Not because you broke it, but you've had some, or also sometimes I just like to hear, I need a better term because I'm trying to like demilitarize a lot of my language, but I would have said a war story, right? Okay. Like tell me a gnarly war story. And that's a real good way in some ways to really suss out like experience, if that's what matters for that role. Some roles it doesn't, so it's not always the right thing. So anyway, back to your thing. So I think those are like the three pillars, if you will, or not even pillars, but requirements. If I'm going to say is something infra code, those things need to be true about it.
Okay. It still needs, those are all adjectives. It still needs, so it's code. Code is the noun. It's testable, abstractable, versionable code. Period. That's our definition. Well, you know what, another piece, I guess we could bring it into here. So, okay, here we're going to get into a thing that people like to fight about as Andrew Clay Schaefer, who created the word DevOps, likes to say. He has a great tweet that says, who wants to argue about the definition of made up words with me? So, and the answer to that is tech people on Twitter. Us right now. Yeah.
Right. Us right now. But one of the things, so I do want to bring this up because it'll come in is, there's certain things when we talk about how infra code and all these things work where people want to argue about declarative versus imperative. And is it idempotent? That's another one. We used to love to use the word idempotent. So what idempotent means is actually a math term. That means that the same operation will always result in the same, will always give the same result. And that's actually a really important idea in infra code and config management. It's incredibly unimportant to know that word. Okay. But the idea is really important, which is I always get the same result. I put this in, I always get the same system out.
Should it go in our definition?
I would say that it provides predictable. I don't want to use the word idempotent because I also think it's too nerdy on it. But the other thing you will run into, I thought it was important to know, Fusebo says, I thought it was important to know the word, but not what it means. You are a thought leader. The other thing.
Someone in chat who has an interview with the CloudFormation CDK today. So best of luck.
Yes. I think the other thing that where we get pedantic about is declarative versus imperative. And this is the thing that there's probably less than 1,000 people in the entire world who actually give a crap about this, but we're all really loud and we talk to each other on Twitter. But most people actually just want something to get shit done. And that's a very important thing to remember is most people using any of these tools really doesn't care about declarative versus imperative. They care about if I do this thing, do I get the system I want? And Chris Nova had a really good quote about this. I can't get right, but that's fundamentally what she was saying, which is most people don't give a crap. They just want to know that I will have a predictable system when I do this. So that's what this matters. Now, the question says, does idempotent imply declarative instead of imperative? So just for a background about what were this sort of like nerd fight about declarative imperative, right? So imperative is stepwise, right? It's saying, do this thing, do this thing, do this thing. Declarative is saying, this is the state that I want to be in. And I will give you the clue, like most, even tools that people might think are imperative, like Pulumi, for example, or Chef, are inherently declarative. And what that means is that you use an imperative programming language to define a declarative state. Yes, I will have a predictable system when I do this. That's all we want. There we go. Show's over, right? That's what the reason declarative matter. Like now to take that away from kind of the fuzzy, hand wavy nonsense of it is declarative configuration management, which is what all this stuff is, even though we call it infra code and infrastructure as software, it's still this, is at the end of the day, I think of it as a test and repair loop. Okay. You are telling the system, I want my thing to look this way. The system checks and says, does it look this way? Yes, cool, do nothing. No, make it look that way. So that declaration of state could be, I want an EC2 instance of type M1 that is this. Is there anything there? Nope. Well, how do I fix it? Make it be there, right? There it is. You've just learned everything you need to know about infracode. That's the entire thing. It's just one big test and repair loop. And it's about creating and enforcing a desired state. So how we define that desired state doesn't really matter. But having a desired state to compare against is what we're creating. Yes, that creates and enforces a desired state. Yeah, I love it. That's perfect. Yes, that is true. As Food Table says, assembler is in some sense declarative. We can make the words dance however we want.
We can and we will.
So there is a question, which I think we're going to get into, but I just want to address it. So Skulzer says, what makes infracode testable? Being able to easily instantiate and observe the final state is what is expected. That's one way to test. And there's a reason I'm actually vague in that it's being testable, because there's lots of different ways to test infracode, just like there's lots of different ways to test all kinds of code. When you think about the inverted pyramid, I don't know it's been a while since I've talked super test nerdery, but just at a high level, we have unit tests, we have functional tests, we have performance tests. All these things can apply.
Integration tests, load tests, smoke tests. Yeah.
Yes. So when you think about where you test, again, it's our ability to, is our code going to do the thing that we expect it to do? That's what test is, Yes, said, I thought infrastructure as code is deprecated thanks to Docker and K7. Yes, it's Docker changed the word. Everything got thrown away. Yeah, so, that's fine. Everything's out.
Lola. Hello to
Hi,
Lola.
Lola.
Is Lola a 10-year-old who might do a conference talk? Lola, you should do it. All right. Oh, and Olaf has a great topic. I love getting everyone foundationally together on definitions before we jump into the discussion. I think I personally just need it because
sure. Okay, so we've got, I'm trying to think. Okay, so you've got, I like that. It's testable, abstractable, versionable code that creates and enforces the desired state. It's aka a test and repair loop. Those I think are kind of the most key things, because a lot of the other things that come to mind are situationally dependent, right? As to what your particular thing, a test and wow, yeah, some good ones there. It is I see you have seen my chef code in the past.
And Java Grunt says that their older kids, Lizzie and Logan, recognize you from Arrested DevOps.
Oh, hi, Lizzie and Logan.
So would the word deterministic fit in this definition? What does that mean?
Yeah, I'm interested to know where I think we're getting outside of my software engineering specifics. So I'm going to give that answer maybe. But
and I know
let's think about that a little bit. Maybe we'll come back to that one.
And I know you have a hard stop at noon, so we should probably make sure we get. I mean, we have plenty of time, but also we should.
We have plenty of time, but
not
also
go too far off the rails.
Just like we talked about with Sophia's talk, where I was like, "We got all kinds of time. It's in 6 weeks." And I started looking, and I'm like, "And you have 30,000 other things you're doing because it's the summer and you're a kid. So shoot." Predictability. Okay, deterministic being predictability. Yes, that I think that's you could say that it's in a predictable way, because that goes all the way back to us saying that's fundamentally what we want, right? We want predictability and repeatability. And I think to me, I think the problem I was having there is that I was assuming that was implied, but that's a danger. So,
well, and isn't the idempotent word that you mentioned about predictability too?
Yes.
We kind of touched on it.
Yeah. So, but I would love to rather say repeatable and predictable because that's more accessible. So I think you could say that creates and enforces a desired state.
So you want repeatable here?
I would say that repeatably and predictably creates and enforces a desired state. I would put it after that. I would say infrastructure as code is testable, abstractable, versionable code, because the code it's the idea that it's repeatable and predictable, or repeatedly and predictably. Yeah, because they're adjectives. Repeatably. I want to see if anyone's jumping on our new Gartner Magic Quadrant buzzword.
All right. So the question is, how is infrastructure as code more than just the code? What are the concepts we need to understand behind infrastructure as code to make sure we get the best value from using it?
The code part is, in a way, kind of the easy part, because that's what leads us to being like, because otherwise, why is Bash not infrastructure as code, right?
Yeah.
And also, some of the stuff we write as infra code is not code itself necessarily, and that's not a gatekeepy thing. It's just, to me, code is, has things like conditionals and loops, and it's code. It's not XML code. We could make this argument, and this is not me saying that HTML is not programming, but and I only say the only reason I'm pedantic here is because are there features of programming code that are useful that we lose if we don't have them? That's why, not because of you have to know how to do it to do this work or any of that bullshit, but like yeah. So when we go,
JavaScript has an interesting test that I'd like your take on. One of JavaScript's tests for is this infrastructure as code is, can I destroy everything and rebuild it the same way?
Yes,
I think
I think that is a test of your actual infra code. Most tooling will, not necessarily do that for you, but yes, and that goes into the kind of also immutable infrastructure approach, right? The idea of immutability is that instead of ever trying to fix something, something's wrong, just create a new one, which we can do in the world of the cloud resource so much easier than we could in the old system. Although it's funny how that immutable thing goes all the way back to like how we did desktop support in some places I was in the 90s, where you would have everybody kept their data. I mean, think about this. Desktop support people have been doing immutable infrastructure on people's workstations for decades, which was keep all your stuff on the H drive. And as soon as I can't figure, I will spend about 15 minutes trying to troubleshoot your problem. And then I'm going to re-image the box. That's immutable infrastructure. So we all think we're doing crazy new ideas here in the cloud. Our desktop people have been doing that since 1995, at least. Right? So, yeah. But when we talk about it being immutable and repeatable, that's the thing. We should be able to say, like, okay, we don't know what's going on here. It's just as easy to build a new one. Can I just destroy it? Can I build a new one immediately? Maybe not immediately, because no matter how good your code is, it could still take a process, especially if part of your infra code is installing SAP. But I think your definition is good. But now let's, like you said, let's go to like what are the things beyond just writing your Pulumi program, your Terraform plan, your chef recipe, whatnot. I was going to see if I could get them all right of all the different terms for the exact same frickin' thing. So a couple of things, and they go back into some of those pieces that were the components of what made it infra code, right? So maybe we'll start with the testing. So now, infrastructure as code for a tool that would do it needs to be testable. For you to use it, it needs to be tested. Just because it is testable does not mean you are testing.
That's an important distinction.
It is, right? Like I have a lot of things I use that have all sorts of test capability. It doesn't mean I wrote any tests for it. So there's a couple interesting things that happen. Like we talked about, you can test starting, again, if we start all the way to quote the left, like your smallest and fastest type of test is like what you would consider a unit test. So unit tests, they run in memory. You don't actually, they're testing like its name implies, one unit of your thing. It's not running your whole program. It's doing that. This is what gets us into a lot of, what do you call it? Misnomers about or false incentives about code coverage. They'll be like, oh, I have unit tests for 80% of all the code I wrote. Awesome. And the 20% you don't have tests for are the most critical. Good job.
Yeah.
Right? I don't care about the other 80%. But the thing that's nice about like unit tests is because they're super fast, like they take a second to run. Like that's how long a unit test should run. So fast that you can be constantly running them as you're writing your code. And it's just your way to sort of catch yourself usually in a lot of ways. Like, is this portion doing the thing I expect it to do?
So should they be constantly running? You said they can be.
It depends.
Okay.
That's getting into like some software engineering, determine how you want to do it. You have the capability of doing it at the way that you want to. But I will tell you, one of the dangers you can run into with unit tests is, what are you actually testing? And I'm going to bring this back to Chef, because this thing I saw a lot is sometimes in infracode testing, especially, we write unit tests that are actually just testing the tool. So apologize that I have not updated my example here to the cloud world. I'll catch up to the cloud one of these days, I guess. But say in Chef, I was going to write a Chef recipe that was going to install a package on my Linux system. Okay. So the Chef code to do that would be, say, package nginx. Okay. Awesome. So it is incredible. That is one line of code that does that. People, this is our unit test valuable in infrastructure code. I'm going to tell you exactly when they are, but most of the time they're not. So if you wrote a test that said, does this line of code, package nginx, install the package nginx? All you're testing there is that Chef does what it said. You don't need to test Chef. The Chef people who wrote Chef have tests for that. Same reason that you don't write tests for, does the C# compiler work when you're writing C# code? Now, the test needs to be testing some logic. Okay. So look at this example. So again, sorry, we're going to get into some operating system nerdery here, but let's say so nginx was easy because the name of that package is the same across RHEL and Ubuntu. But then if you look at Apache, the Apache package has a different name across different operating systems. So my Chef code couldn't just say package HTTPD or package Apache 2. It has to basically say, if OS is RHEL, then package equals this, and then does that, and then run that against the input and say, does that work? Because I have now changed things, right? I have put in a branching logic. That's what I want to test. Now, the reason unit tests to me are actually very helpful to catch things that people don't remember used to be a problem. So even in that case, you're like, man, you don't have to write a test for that. That's like pretty clear. That's either going to work or it's not. But you want that to exist in your test suite all the way down. And you'll sometimes find that like there is some really interesting both history and scar tissue that ends up in testing suites. This is not an infracode story, but I love this story. So I want to say it was in 2005. Firefox Mozilla, they released a new version of Firefox the day before the World Series, and it broke MLB.com.
Oh, no.
So at least for years, the last time I knew somebody at Mozilla who knew their test suite, but for a good 8 to 9 years, the build tests of Firefox contained a test of MLB.com, right? And that's a little bit of a funny, like, oh, ha, ha, ha. But it's also like there's a thing there. So we don't expect, because tests are a form of communication, right? Version control is a way that developers communicate with each other. This is our way of testing those things. So, but unit tests, in a way, to me, are the last tests you give a crap about writing in your infra code. When you've got all your other tests handled, then you can go kind of deal with this stuff, okay? So the next kind of place you'll run into, and this is sometimes people might call it an integration test. I would say you have a functional test. So the difference was, again, and if we're going to talk about infra code, to do a unit test, it doesn't actually do anything, right? It's just it's executing the code in memory to sort of say what would happen. Well, then if we want to do a functional test, it's like I actually need to make the thing and then see what it looks like, right? So in the case of older school config management, it would be I actually have to spin up a VM and then run a test against it and say, so to go back to our Apache test, right, which was in the unit test, it just says, would Chef think it should install this package with this name? A functional test would spin up a virtual machine, apply the Chef code, and then say, but here's the difference. It wouldn't go and say, is Apache installed? Because actually what I'm trying to accomplish there is not install the package. What I'm trying to accomplish is something listening on port 80. Is Apache listening on port 80? So then I would actually run that. Now, those tests are more expensive in time, and you might actually have to spin up a resource. So you usually move them a little further down your chain. And there's a lot of really good tools that get good at either mocking them these days with modern infra code, or even then, you know, if we could think all the way back to like, you know, I know a lot of people know HashiCorp for these days is things like Nomad and Terraform and everything. But HashiCorp started with a fun little tool for running local virtual machines in a configured way on your laptop called Vagrant. And so when we were doing this infracode stuff, instead of like spinning up a VM in your big cluster, could I do something locally with Vagrant using VirtualBox or even Docker? Don't do Docker because then now you're doing a VM in a container. So the same thing even today with things like, you know, with cloud resources, will it actually create this cloud resource maybe in a different environment? You're not going to do this in prod, but somewhere where I can run this test and say, okay, if I run this infracode, will it create these resources that map to my expectation? And then, but that's still going to be within the context of this one resource that I'm trying to create. But usually our infracode, our infrastructure is made up of more than just one resource. So then we get into kind of an integration that says, okay, actually create all the resources, and are they connected all the way through? And again, I always like to think about our testing as testing the service, not testing the technology, right? Like I don't give a to go back to my example. I don't care that Nginx is running. I care that the website is working, because that's part of what I'm creating, right? Who cares if, you know, a database got created if it's empty? Because actually it's an input. So your integration tests should be, how is this being consumed? You know, doesn't mean you have to do synthetic transactions and automate like someone going and adding something to their cart, but just like wherever the contract points are and see that. And as we move these, this goes back into when we think about things being versionable, and this is also why applying software development practices like continuous delivery pipelines and stuff to our infracode allow us to do this. So I can say, okay, these things can run automatically, so I can have predictability, so that I can. This is the testability of this is what allows the predictability. Like it gives me the confidence that when I deploy this change to this new version of my infracode, that it will get the result that I'm expecting.
So we have the chat is just blowing up.
I know. I was going to say, Fool Stable says the tests you describe are much more difficult to write than unit tests. So I prefer to write unit tests that bring little value. Everybody, yes. I'm in this picture and I don't like it.
So it's not just testability, though, as you said. The testability results in predictability, but the test, you have to actually test it for it to be. Just because you can test it doesn't mean you did test it. So if it's tested, then it's predictable. I'm gonna write that.
Yeah, I think that.
That's how you get predictability. Findle, it's so good to see you here. I misspelled infrastructure earlier, the very first word I put on the board. Findle, jokes that they're going to write me some spell check software for my light board. And so what, can you give me maybe an overview of the major concepts that you hope to cover so I can have a sense of how much real estate I have on the board?
Sure. I think they are those three.
Testability
and abstractability, I think. And then, because the versionable is going to come a little bit to sort of how we organize the way we think about our infra code and make it accessible to other teams.
Okay.
So yeah, so excellent. I think you're about a third. It looks good. You're thinking of about a third. That's about right.
Okay, great.
Okay. So let's take a minute, because I think the abstractability will lead itself into how we reason about, because the versionable also has to do with how do we organize our infra code a little bit, right? Mm-hmm. We can get into like, do we have multiple repositories? How do we break it up? How do we break up responsibility? And like the abstraction comes into that. So one of the things when we think about the power of creating things via infrastructure as code is if we build something by hand, so to speak, we have to know a lot of things. Think about creating and configuring a Kubernetes cluster, for example. There is a lot that goes into that. Okay.
Yeah.
Most of those things are things that most people don't, I don't want to say they don't care about them, because people, that's a value statement, don't have the knowledge, or it's not within their domain to have to know what to do with that. And it's outside of their remit to actually, not, I don't want to say not to care, but to know what's right. So,
there are like 60 different objects in the latest version of Kubernetes, different types of resources. And then there are thousands more on top of that if you count all of the custom resource definitions from other stuff. And nobody can care about them all, even if they wanted to.
Yeah. So what we want to do with this is say, how do I expose just the things that are my area, either my area of expertise or just the thing that I should reason about? And let's say within our organization, because again, we've talked about this, DevOps, 10x, none of this means everybody can do everything. We have our areas of domain expertise. Okay. So we have our subject matter experts inside our organization who are really good at how Kubernetes should be configured and have their requirements even, right? So let's even take away from the whole cluster, because most people are not necessarily, say if I'm a developer, I'm not necessarily going to, hang on. Sorry, we're having a little bit of a scheduling crisis about my son's baseball tryouts are the same week as Sophia's talk, so I'm having to.
It's I think Deshaun, I know, has 4 kids, could probably relate to. Findle says, I love having tests, but I hate writing tests. So logically, I love people who love writing tests.
Yes.
Yes.
Okay. Is he trying? No, he's actually trying out for, my son is trying out for the junior high baseball team. So but
exciting.
It's kind of a big deal. So we're trying to balance that. Okay. So the idea is, so say a deployment into your Kubernetes cluster, right? There's a lot of configuration that goes into just a deployment, right? To a Kubernetes deployment. I'm a developer who just wants to deploy into that cluster. I don't want to have, honestly, I may not know what are the right things. There's a lot of dials to set, a lot of things to set. And I can say on the cluster admin side or the Kubernetes subject matter expert side of my organization, there's really only a couple things I want to let you do. So one of the ways I can do this is I can say like, okay, well, I don't really, I want to keep you safe. So you can just tell me what you want and we'll do the deployment for you. Well, that doesn't scale. I don't want to sit and tell you like, go ahead and write the code that does all the stuff. But if I can create an abstraction that says, this is what this is a Maticorp Kate's deployment. And I'm going to only expose in that abstraction 3 properties, right? There's dozens of properties around a deployment. Of those dozens, most of them are this. We have a set of good practices of common practice for our org that you don't even set. That's just how they are. But there's 3 properties that matter to you that are, you know, it needs a name. Okay. What's the container image? Maybe, right? You know, so you get to do that. And so what I'm doing is, yes, you know, so if I can create a component, some type of an object, an abstraction that instead of that lets me bring that into my infra code as a developer that has those properties, then it's really trustable, right? I can't, first of all, so I can't mess it up, you know.
I have a question. Is it the ops person that's creating an abstraction and then able to hand that abstraction to a developer to use? Okay.
That would be, and again, in this example, it's a dev and an ops. It really doesn't matter what their job is. It's just the expert in this domain. Think about it the same way that packages work in a programming language, right? That you know, if we create a package to reason in a certain way, that's a library, right? It takes a few inputs and it does a bunch of stuff in a standard way. That's what an infra code abstraction does. It says that's how all resources, frankly, work in code, right? It's an abstraction. It's like I'm not writing code that talks to the AWS API. There's an abstraction, which is VPC, that has a set of properties to it, right? And what we can do is ourselves, we can then even create, so that's the core of it, but that becomes even more powerful within my organization because I can repeat that to really narrow it down. And the thing about guardrails like that, I think they're powerful. Number one, it gives a sense of ability to say like, okay, I'm not worried that Whitney's going to go and do something to take down prod or whatever, but also it tells Whitney, I don't have to worry about taking down prod. Like I know I have my space I can rattle around in and I can do it in a safe way that only that limits the blast radius to just the things that I do something with.
So abstractions equal guardrails. R-A-C-T.
That is they provide, one of the things they provide is guardrails.
Okay, I like that. What's another example of an abstraction? I'm finding the examples is the best way for me to wrap my head around it.
From an infra code perspective, that's kind of fundamental. I mean, that's one specific example, but like it's so we gave it like a Kubernetes thing. Kind of gave the example in AWS, which would be like at its core, because when we look at how infra code works, regardless of what it is, it's all still based upon this idea that you're defining a resource that has properties. So a resource is a thing you want to care about. Can be an EC2 instance, can be a Kubernetes deployment, can be a VPC, can be a DynamoDB instance, Cosmos DB instance, and it has properties, right? The properties are, you could even reason about them as being, those are the settings, right? If that helps. So, but as we move the levels, the thing is we can move the levels of abstraction around. So even at the core, like the example I gave, the Kubernetes deployment resource in, say, Pulumi has tons of properties on it. We're saying, can we set some of those and create an abstraction on top of that to make it easier for me to only sort of have my little narrow view of the stuff that is important to me? And this is always really hard to talk about without it sounding like we're like, oh, because I don't trust you, or you have a narrow, like those are really like, like kind of judgy kind of ways to talk, but they're absolutely true. And in a powerful way and a useful way, because everything, think about it this way. You know, we talk about it being turtles all the way down. Computing is abstraction all the way up. We don't talk to the hardware, right? We're not talking ones and zeros to the processor. There's an abstraction is just a way of, think about it as a way of translating something lower level to something that makes sense to you in your worldview or what you need to accomplish, you know? So I'm just giving you the bits.
Fuel Stable's comments. The purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. That's beautiful.
Yes, that is. That's a really complete and specific way of describing it. So.
Yes. That's fantastic.
So I think that kind of reasons about where that goes. Now, the reason that I wanted to talk about those abstractability parts and how that goes into when we think about organization of our infra code and then the versionability of it has to do with how the things are broken up. So yeah, Dykstra just said it. Yep, that's hey, again, my entire career is just repeating what other people said, and maybe slightly different words. So
for people using abstractions. So, and again, I paraphrased your comment on the board here, but it's all about increasing the abstraction level to reduce the cognitive load on the developer. So I'm loving that. One thing I'm curious over here in the testing, with the unit tests, you kind of said, okay, don't test. You're telling us what not to test. And functional tests, you're like telling us what not to test. Like in integration tests, is there also a trap you can get into doing it the wrong way?
Well, think about it this way. Just like we talked about the abstraction leveling, that's sort of the same thing in the test. As the tests go up, the abstraction gets higher. So the same thing about the resources like pre-made expectation, the integration test, you're probably even bubbling what you're testing even higher at that point. Because you're sort of assuming in a way that the lower level tests would have caught that, or sometimes they're implied, right? That's the other thing. So again, if we think about I don't need to test if Apache is running if the website is up, because the website would not be up if Apache wasn't running, right? So that's sort of why it's like, again, it's a good illustration of abstractions as well, right? Like
and then this is probably, I think I know the answer to this, but I want to ask it anyway. These abstractions that you're creating, do you use them in your testing? Like are you testing
because they're part of your they're part of your code. It's how your code is created. So like, yeah.
Okay. All right. So now I think we want to talk about it being versionable next. Yes.
Yes. 1 second.
Cool. I'm going to talk to Thindle's comment. Thindle said they had a customer who had 0 tests. In 2 sprints, they wrote 3,000 unit tests. A ton of bad ones, of course, but a ton of tests. Everyone was happy. Then the tests started failing as they changed things. So, of course, they commented out the test that failed, and now they have 200 tests. So, but like, how much coverage do those 200 tests give, I suppose?
Well,
like,
right, or they're just the ones that work. There's another really fun story that Jez Humble has been telling for years, and he might have stopped telling it. I keep telling it now, but I heard him tell it years ago. And he said, he's working with an organization where they had a goal for every sprint was to add 2 more tests, which meant they ended up with a whole lot of tests that were assert equals true, right? They were tests, they didn't test anything, but they added a test, and so this all goes back to the whole, like, people work to the metrics you give them, whether or not they actually accomplish anything or not.
One thing that we talked about, I'd like to capture is you kind of mentioned some infrastructure as code technologies. And since it's all pretty new to me, I kind of want to write it down. Like, so I'm
going to try this. Yeah, there's some.
So we talked about Terraform, Pulumi. What else? What's the chat? Help me out, because the other ones that we talked about were unfamiliar to me. I know you keep saying Puppet and Chef. Does that count as infrastructure as code? No, right? Bicep. Bicep and ARM.
Bicep, CDK, Amazon CDK.
Oh yeah.
I hesitate on thinking, Engine says, ARM as in like ARM templates, which I guess if we were to say CloudFormation is like ARM templates, those are both ones. So CDK is different than CloudFormation, but I would still, Puppet and Chef still come in there. They're still in existence.
Cool. And then it seems the way y'all are talking, it seems like some of these are more outdated than other ones, like Puppet and Chef seems maybe more outdated than like Terraform seems like a more current one.
Well, because of the technologies they exist to work on, right? So if you think about things like Puppet and Chef and Ansible are much more about reasoning about operating systems. For configuring, if you were to say configuring VMs or instances of an operating system, which we are doing less and less of, but it is still very relevant. And tools like CDK and Terraform and Pulumi don't do that, right? They're at a higher level of that. So,
and Napalm, you say Striker is great, by the way. Is Striker a infrastructure as code solution?
I don't know Striker.
And y'all, so ARM and Bicep, what can you define with code using those technologies?
Oh, so ARM and Bicep are Azure specific.
Oh, okay. ASZURE. And cool. And Java Grunt says the same thing. And then so are Amazon CDK and CloudFormation to AWS what Bicep and ARM are to Azure?
I think that's pretty accurate.
Okay. And then Pulumi and Terraform are general purpose. Right?
Exactly. Cross, every cloud,
Cool. That's very helpful for me. Multi-cloud. Are you ready, Matt, to move on to versionability?
I think so. Yep.
Versionability. Findle says Pulumi is awesome. Java Grunt says, I'm here for the chat, but staying for the Pulumi.
All right. So when we think about the versionability, so kind of at a high level, the easiest thing is to say, like, it would mean like, oh, I just chuck it into source control, but that just, I can throw PNGs into source control, right? I can throw a PowerPoint into source control. It doesn't mean it's versioned. And the versionability doesn't necessarily mean the version of that copy of the file. That's the thing, right? So that's a good start. If that's all you're doing, that's great to say, like, my bash script is now the version that it was yesterday versus today. But when we think about things like these packages that we're creating, whether they're modules, they're, libraries, cookbooks, whatever we call them in the different thing, they have versions so that we can know the version we're using. And that gives us that predictability, right? We can say, I've kind of locked it and said version 1.2 of my Maddie deployment for Kubernetes or whatever.
So those in the chat, do y'all who use infrastructure as code, is versioning and source controlling your infrastructure as code part of your workflow? And then my next question is, how does that relate to GitOps? It seems similar or almost even the same. Is GitOps a type of infrastructure as code? So
I have a little bit of a thing with GitOps, and maybe part of it is that because I reasoned about that in a very different way before whatever we call GitOps is today. But I feel like GitOps was going all the way back to Puppet, because the way you deployed to Puppet was doing everything through Git, just like Napalm says. But that sort of has been turned into a it's just a configuration that's stored in Git, and it pulls the config from there. It's not, but yes, but pure GitOps is just that the way we communicate and deploy and do things is through Git. You merge it to main, and it gets deployed just like code. That's GitOps. I mean, it's GitOps to me is continuous delivery of your infrastructure, right?
Okay, yeah.
So
and this doesn't have the continuous delivery elements, but your infrastructure is still defined in code, but then it lives somewhere else.
At least it's still in Git. I guess what I'm saying, when something's source controlled, it doesn't necessarily mean even your application code is not necessarily versioned just because you throw it in Git, right?
Okay, yeah.
It's versioned when you give it a version that whether there's all sorts of ways you could do that, whether it's a tag, it's a semantic versioning, but I'm like, okay, I know which version that was defined and tested and confirmed that I am currently running, right? So when I can look at that, I can say I have this node package in my application and it's locked, right? This is giving you the same ability, right? To sort of say again, it gives you predictability, because I say when I run this infra program, it's using this because it's all slurped up into all these abstraction components we talked about. I need to know what they look like so that it's packaged together, and I have that. Yeah. Or again, like Java Grunt says in the chat, that broke things. How do I roll it back? Right. I can say, it's this version, but it's also the versioning is what lets us reuse things amongst each other, right? Like if my source code, if all I have is one big script that is where all of the logic is in one file by itself and it doesn't slurp anything in from anywhere else, that versioning matters a little bit less. But a lot of the stuff I'm creating, all those abstractions are getting consumed by someone else, and I need to be able to make changes to them without breaking other people, and that's where that versionability comes into play.
So version means like a current state is locked. Is that accurate?
A specific state is locked.
Okay, yes.
Because you don't necessarily have to use the current one, but it's so I can say, hey, I'm using version 1.2 of your package.
Yeah.
You can go ahead and create 1.3, 1.4, 2.0, and you don't. But I still can. I'm not getting pulled along for the ride with every change you make, and that gives me that predictability. That's just. These are the things that the software developers listening to this are like, well, of course, that's just what you do with software, but that's why it's important, right? Yeah.
For predictability. And I mean, if you're communicating through these definitions, they need to be consistent Well,
and also so you don't break things on people, so, we'll talk about, there's this convention that's not really enforceable, which is why it breaks as a convention. But if you ever heard people talk about semantic versioning, so what semantic versioning is in a version number, the significant digits mean something, right? So let's say you have version 2.0.1. So the first digit, the 2, that is a major version, which means it can introduce breaking changes. That's a whole different idea, right? Whereas the second digit is like new functionality that could introduce a breaking change. It's potentially a breaking change, but you're not really you're not changing the core idea of it. And then the third digit after that is those are patches. So you're making a commitment that if you're using, say, 2.0.1 and I release 2.0.2, I'm not going to break something underneath you. Like everything that you're used to working will still continue to work. So whether or not you believe in the semantic versioning or not, the idea is, again, it gives me the ability to say, like, okay, when I tested this, I tested it with version 2.0.1. So as long as I continue to use 2.0.1, it will be the same. But if I'm always pulling in latest, for example, that could break, So, okay. Oh, there's a really great question. Deshaun is going right into what I want to talk about. So Deshaun says, does it ever get shared responsibility? Could different parts of an org be responsible for their own Git repo and put that in a supply chain just like their apps? Yes, that's exactly what I want to talk about. So I've written a bunch of stuff on the Pulumi website about like how do you organize your code? And it's a big fat hole of it depends, right? But just like if you're familiar with the precept of Conway's law, which is your software architecture reflects the communication patterns of your organization. Your infra code, we could call this I don't know. I'm gonna be a jerk and name it after myself, but the corollary of that in infracode is your infracode patterns reflect your software engineering patterns. So if you work in a mono repo, then you're probably going to find that your infracode works mono repo wise. That's how your teams are broken up. If you use a ton of microservices, then and micro repos, if it's not a monolithic, I know mono repo is not a monolith, but again, the way you break that up. So your infracode boundaries wrap around areas of responsibility. Okay. So the more abstractable they are in something you can publish. So if I can publish a package that's consumable as this gives you a Kubernetes cluster, then I live in my own place and you just slurp it in like you would slurp something in from the public internet, right?
Yeah.
So and that's really powerful. And I have seen organizations that their biggest use case or business case, really, a driver for something like Pulumi specifically, and why they like Pulumi is because they can do that. So think about, again, building a Kubernetes cluster, right? Or if you're even deploying, let's even make it as simple as deploying a cluster is big and complicated. Say deploying a resource in the cloud, right? Like there's a chunk of stuff you need, maybe even an EC2, right? Just getting a VM out there. Okay. So in a lot of places we'll go back to the cluster. Okay. A lot of places you're like, I want to deploy a new cluster into production. It probably needs to get reviewed by security. And that takes time, right? I have to sit there and say, okay, I'm bringing up this new cluster. Now it needs a security review. So my InfoSec or DevSecOps team has to come in and do all this stuff, and it takes forever. But if there's this package that's created in my org this is Matty Corp's Kate's cluster, and I can only touch a couple parameters on it, but the only way to deploy it is using this version that's been stamped by security. Security probably goes, and a lot of orgs goes, that's fine, because I don't have to, because I tested it in a way you can think about that these components, these abstractions, they're templates. But templates that you can only edit parts of, right? Because most templates, they're a starting point. You can change whatever the hell you want. But imagine it was like a Word document. Think about it this way: you might get let's take it all out of tech and let's talk about like a legal template from your legal department. You probably
I love that.
Think about it this way: you have an NDA that's a standard thing that if someone's going to come do a thing, and you get the NDA template from legal, and you can edit like 3 things in it. You can probably put your name in it, the customer's name, the date. Okay. And that's fine. And legal's cool. That's all you have to do, because you can't go and edit the words that changes what it does. You can only change the things that I don't actually care if you change. What if you could do that with your Kubernetes cluster? So then security, instead of legal, says, cool, I don't care. You can turn these dials to whatever you want, because they're controlled. You can only turn them so far, and you can't turn any of the dials that introduce the things we're nervous about, right?
Break. Yeah.
So now, as a user, this is amazing. I went from like, oh, shit, I want to deploy a Kubernetes cluster. Well, I better bake in 2 weeks to wait for security approval, or I literally can slurp it in, put in my code, run, done. I've got it in half an hour, right? So that's really, and that's win-win for everybody. Like for me wanting to do it, I have greater velocity. It gives a huge amount of, it takes load off of your security team, who, again, back to what we were talking about with the ops people, right? Like we want our security people using their big brains to like think of best practices and how to do things and defend, and not be like, okay, well, let me run a pen test. Let me go look at every setting in here and do whatever. Like that's a waste of their resource. And it gives them a little bit more confidence. So everybody is happy for the most part.
So what I'm hearing is different teams.
Because
what I'm hearing is different teams can define abstractions based on the abstractability that we talked about. And then those abstractions can be tested and then versioned, so they can be distributed out like throughout the whole system, but to other teams to consume. This is beautiful. Yeah. They're
just building blocks, and
building blocks.
I think that kind of handles those things. Like, I think we got it pretty well covered.
Yeah. Yeah. We have a lot of comments. We have Fuels people have some stories about
Yeah, I would love to revisit some of the
Timber.
stories.
We'll go. Different packages take Timber at different levels of seriousness. We don't want to bump the major version because it's a hassle to a lot of people. Then they just bump the minor version, but there's still a breaking change.
Yeah, semantic versioning can be a little bit of a lark.
So then others have been saying we don't really care about ABI. I don't know what ABI is, but C# and Java ABI is what matters. You have to teach me, school me.
Hang on, I'm looking to see where that.
And then of course, optimized Scala libraries take the implicit dependencies on private parts of their dependency, meaning even a patch change is a major change. It sounds exhausting. Fuel Stable says, I've been hurt. Fuel Stable, I adore
Story for
you.
all scar tissue.
Findle says, I love slurping the internet. It has electrolytes. I've been enjoying your liberal use of the word slurp too. So policies are written by different teams and personas. That's what I'm getting, and I love. Dan Basket Case is here to tell me that ABI is Application Binary Interface. So Sean says, I feel like we're going to learn a cheat code for how ops teams can add value by providing some control to apps teams using something like Pulumi. They're really egging you on to talk about Pulumi today. So what I understand of Pulumi is that some of these tools are no good because they only do operating systems. Some are no good because they're cloud specific. So you want a multi-cloud solution. And then between Pulumi and Terraform, my understanding is that Terraform has specific language you have to use, or specific, they've already defined exactly how you need to talk about infrastructure on their terms. And Pulumi
I want to be really
lets you use your own programming languages.
Clear, even though I work at Pulumi, like none of this is, I'm going to hesitate on that they're no good because, like I said, should I use CDK or Pulumi? Yes. Should I use Terraform Pulumi? Yes. But there are reasons that all of these really great tools, and I know the ones I prefer, but they are because they're the things that make sense to me. And I think can empower in different ways. So, because this is just the nature of the beast, right? Like I'll be at a conference working the Pulumi booth, and people want to come up and be like, "Well, we have all this in Terraform, and I love Terraform." Blah, blah, blah. I'm like, "Awesome, continue to be awesome," right? Like I'm not going to come and tell you to like get rid of a thing that you love, because are you getting shit done? Yes, cool, continue to do that. Are you having problems? Awesome, let's talk about it, right?
Yeah.
But the differentiators and where those go. So like, for example, something like Bicep or something that's really hyperscaler cloud specific has some advantages, right? Because it's really good at that, but it's only really good at that. And the reality is, I'm not even talking about multi-cloud, like I've got stuff in GCP and Amazon and whatever. I'm talking about my services are made up of more than just AWS. There's PagerDuty and New Relic and Datadog and all these other things that all combine together. So that's why, to me, I like a solution that is more agnostic or is more cross, right? And I think the big one, there's a couple there. Then there's some other idiosyncrasies, not even idiosyncrasies, but some other things that I think are really, really awesome with Pulumi that you just don't have somewhere else. And one of those things is and this goes a little bit beyond into what we're talking about, but there's something called the automation API. So all the things we've been talking about are basically writing a program or a script or a thing that we run to do this. And it could run in a pipeline. It could run in a batch in a cron or something like that. But what you can also do with Pulumi is you can actually even bring all of that infra code into your own application itself and run Pulumi as an API inside of all those programming languages. So there's a workshop I've given where we build a Flask app, which is in Python. So it's a web framework for Python that creates a portal for doing Kubernetes deployments, but it's Pulumi behind the scenes. But I'm not actually having to like write Pulumi code. You know what I mean? It's like it's letting me in my application. So there's all sorts of ways if you're building developer portals, if you're creating your own automation platform inside your organization, then using Pulumi inside your code. It's really I think that's really exciting and has a lot of potential. Is it appropriate for everybody? No, right? It's like everything else. All of this is a big fat bowl of it depends. And we live in a world that's really amazing that we have a lot of awesome choices. Right?
Yeah.
you know, and everybody is, you know, what do they say? You know, a rising tide lifts all boats, right? So, you know, and I used to joke when I was at, you know, we used to say when I was at Chef, and, you know, should we fight against Puppet? And we're like, there's a ton of market share for us to steal from Blade Logic. And for people who don't know, Blade Logic was a very clicky way of configuring, you know, Linux and stuff like that. And there were tons of people that's what they used in their org was Blade Logic. And I'm like, that's who we go. Those are the people we need to bring over, because it's not so much we have to bring them over to our tool. We want to bring them along to this way of doing work. And that's the thing that to me is what makes all of this really important. And having done things the hard way for so much of my career, it's just amazing to be able to know that this is helping people make things better, and their work is better, and they can do more awesome things with whatever tool they're using. I have my preferences, just like people have their own preference for programming languages and IDEs and text editors, for crying out loud, right? So yeah.
We have some comments.
Yes.
If it ain't broke, don't try to fix it. That's great. The automation API is gold, so that's a Pulumi thing, right?
Yes.
And then infra as software. So the infrastructure is code, infrastructure is software.
Infra is software. So infra is software has been reasoned about a couple different ways. I'm happy to. I've said it quite a bit. I really like it. Chris Nova talks about that quite a bit as well. And that's, but the difference sort of like in that follow-up where the comment said infra is software and said Terraform being infra is code only, is again, the software is again, all of these things. The code is just the code that we're writing. So when we talk about infra, there's more to infrastructure as code than code. That's actually the whole idea, is that it's treating it like software, the same way that we release and test and work with software. That's the same thing as our code, as our infra code.
So one thing I would like to go over is like when you're considering which infrastructure as tech to use, what are some of those considerations? So if it's not broke, don't fix it, right? Not broke, don't fix.
Yes. So when you're thinking about like, how do I decide, right? Partially, it can 100% be like, what do you already know? Like, where are your skills? What do you know? One of the best tools is the tool you already know, as long as you can do the things you need to do with it, right? There is I will see if I can find it. So my coworker, Lee Briggs, he had a really interesting Twitter thread a while ago that was choosing an infrastructure code tool here in 2022. And then we ended up doing a live stream about it, which the reason I'm bringing this up is I'll find the link, but also that was an hour-long conversation, right? So there's a lot to dig into that. But a lot of it just comes down to what experience matters to you and matters to your team. And also, again, part of it is like, hey, if I'm in a world where every darn thing I'm doing is an AWS service, that's where I live, then you know what? Amazon CDK might be perfect for you, right? And why make it more complicated? Or even that's not to say that the other tools aren't good, but like you might work well in there, right? If you know HCL, which is Hashy Config Language, that's our hash, that Terraform uses, and you're really good at it, and your team is really good at it, and you have a lot of like prior experience. So it's then that's awesome. Like do the thing that lets you, because again, we don't write infra code. Infra code is not a product in and of itself. It's all in services of us figuring out how we get value to our customers and our users. So that's the thing, is look at and say, how does this let us? Does it need to make the tent bigger in the organization? Does it need to empower other people? Do we need to have like really rock solid predictability because stability is an issue? There's a lot of factors that come into that. And the biggest thing to remember is that the biggest advice is there is no right answer. So anyone who's going to tell you this is right or wrong probably has something to sell you. Right. I mean, one of my favorite sayings of my own is, you can't buy DevOps, but I can sell it to you. Right. Or we can take it another way. Right. And here we go. I'll make it go. Every single one of these tools is going to have something that's going to piss you off. And now we will go and do The Princess Bride. Life is pain, Whitney. Anyone who tells you otherwise is telling you something. So there's every one of these tools, which I think are all really awesome, have their own kind of pain, you know. So, but is it a way that makes sense to you? And is it something where the benefits outweigh that? Or again, what's a big amount of pain for someone in a certain tool is a little amount of pain for someone else. And you know, your bug is my feature. You know, there's a lot of people who look at, like, I consider something like Chef and Pulumi. I'm like, it is a benefit to me that I can do anything, right? I can write anything because it's code. There are people who say, oh my God, that is the scariest thing I've ever heard. I don't want to be able to do anything. I only want to be able to do what I can do. I want really strict guardrails. Cool. You and I are different, right? And it doesn't mean I'm right or wrong. My use case might be different. So remember that. I'm going to find that.
And I have a comment that chat today really loves Pulumi. I was worried about Pulumi. Napalm says, I was worried about Pulumi from an AWS perspective, as the AWS CDK is so close to the platform, it makes common patterns easy. Then you guys hit it out of the park and said, okay, use that, but it's faster and can be mixed with our stuff over here. Genius. And so that's talking about the API.
The CDK interop,
The CDK, cool. Should I have a little space over here? I can use it for Pulumi love, because people seem to really want to go there.
Can you draw a platypus?
Oh gosh,
that's our logo is a platypus. The
no.
Okay, fair. I didn't want to put you on the spot, but I thought we would try.
I can draw what I see, but if I don't see it, I have a hard time conjuring it.
Let me see.
But also, like, I think it would be good for either like a recap, or I also think it helps my mental model to go through more examples. Like we talked of, for abstracting, we talked about example of a DevOps, a Kubernetes deployment that is hardened in a certain way by a certain team, and then using that to version and then test. Like, what's another example of an abstraction that could go through this process that's tested and versioned?
So, okay, you know what? I'm going to actually, we'll bring it back a little old school for this, because the example I used to like to give. So just any kind of an application server. So whether we're talking about like WebSphere or Apache Tomcat, you know, a Java application server, it's the same thing. I need to get one going. I need a place to put my application. But there's a lot that goes into building a Tomcat server, but I really only care about a couple things, or just a web server in general, right? Think about just an Apache server. So a server, you know, and I don't necessarily mean the whole operating system of it, but sort of the container that is the application server or the web server, you know, so whether it's like Apache or Tomcat or WebSphere or, you know, so I think those, I would say, you know, say application server actually would be an example.
Okay. And chat, WebSphere says Deshaun, chat, help me out here. What are some things that y'all abstract in your own infrastructure as code solutions? So application server is great. That helps me. Application server, so you talked about a Kubernetes deployment.
You could think about like,
here's a question for the there are quite a few app developers in the chat. Like when do you touch infrastructure as code? What's your experience like?
That's a really good question. I'd love to know.
Yeah. Deshaun says, be AWS, GCP, Azure experts versus expert of the abstraction across clouds and having a tool that works on all of the things. You don't even have to sell Pulumi, Matt. Pulumi sells itself, it seems.
I mean, welcome to the way that I do all my work, right?
Yeah. Okay, so Deshaun has some Kubernetes clusters. Load balancers would be something that could be abstracted and defined in infrastructure as code. Networking.
There's actually I'm going to give while you think about it. So there's a Pulumi. I hesitate to necessarily call it a feature. It's a thing we publish that is actually a really good example of this. So it's called, the name of it is Crosswalk, but it's Crosswalk for AWS. And so the thing to think about is if you were to want to spin up a say a container registry, right? There's a lot of other things that go along with that, right? That you don't really have to. And so instead of having to like create all those resources one at a time with the AWSX, with the Crosswalk, I have one that sort of implies all of that. So that's another way that abstractability and these come up, is to also say, here's all the sub things that have to get done also, and you treat them as one big glob. So that's where that comes into. Like, think about even put it this point, like you wouldn't do it this way necessarily, but let's say, well, even think about you wanted to create an EC2 server in Amazon. The EC2 resource is just one of the things that goes up, but you're always going to need, or not always, maybe you always need to have, some S3, some EBS that goes with it. You need a VPC. You need, or load balancer that goes in front of it. So those are all, the way you can tie them together, because you always have them together, and then you treat them as one resource that has a bunch of properties. But really, when you look at what Pulumi or whatever did behind the scene, you're like, oh, damn, it just created, I just have in my code, I have one resource, but I look at what it did, it just created 10 things for me, but I didn't have to think about each of those 10. So that's that abstraction that comes into place too. It's not just exposing only what you need to, but also just what do you always need? So you don't have to remember, and you don't even have to tie them together. It'll happen in your code, the code of your user. So
that's amazing. That's great. Napalm says that they build an AWS API gateway pattern that is truly private to their VPC with custom domain capability. Surprisingly, not private by default. So we need a private one off endpoints, and rebuilding that every time was a chore. Now I drop in a component and life is good. Well, life isn't all pain. See that?
Yeah. No, absolutely. I mean, it's really, a lot of this is just codifying your good practices, your common practices. Putting them in code that's repeatable. That's the fun thing with a lot of this stuff. You start talking, it's just like I talked about with the DevOps thing with my daughter. A lot of you are just like, well, why wouldn't you do it this way, right? Like these are not complicated ideas, but you have to kind of have some intentionality to think about them being there.
So for examples of abstractions, especially ones a developer might care about, would be managed services on a cloud provider. That makes a ton of sense. It can be tedious to set up an instance, right?
Yeah, for sure. Right. And to have, again, and it's like, I have seen places where this goes. I think it's the company, this is the case study, so I can talk about it. So there's a company called Green Park Sports, and I talked to them a bunch about how they did their Pulumi stuff. And it's like, there's a thing every time they bring up a new service, and it's not like a managed service. It's just like in there for a dev team. You're going to onboard a dev team. There's a whole bunch of stuff that always happens. Right? So you have to get the GitHub repo exactly the way, with the right permissions. You have to set up Datadog. You have to do all this stuff. And so having kind of an abstraction, so all I have to do as a developer that wants to create a new thing is basically just create an object, if you will, a component, a class of whatever that is my thing. And it's like, well, this is all the things we do based upon those parameters. And it's codified too, so I can continue. I can do a GitOpsy thing, which is, I changed the thing. I just push into the repo, and it goes and does all that. It's not just because that's the thing too. A lot of this is not just day zero stuff for when you first started, but also how do you keep that stuff enforced?
Yeah, and that feeds right into what Fuel Snable is saying. I think for an abstraction to be valuable, it needs rules of when it applies and what it provides. Yeah. Otherwise, how can we have the precise new layer of semantics? Yeah. That's great. I'm feeling some wrap up vibes. What do you think? Do you think there's anything else we need to? So we got, we literally can't talk about anything else because I'm interested. Deshaun, you mentioned networking as an abstraction, and I honestly don't know enough about networking to know what that would look like as an abstraction. Is it like a Kubernetes network policy object, or what would networking look like as an abstraction? And then Fuel Stable says, fill the screen again. Fuel Stable, the secret is I usually have some things going on in the background. Like if there's room, I will draw this. And then otherwise, if there's not room, I won't draw it. So it seems like it just magically works out perfectly. But really, I have a backlog of ideas going. I just showed you behind the curtain. So forget it for the future. So is any last word from chat? Hopefully Deshaun will get back to me with the networking question answer. And we have everyone will go support Matt's daughter's talk at DevOps Days. It sounds like it's going to be streaming for us, so that's exciting. And you can follow Matt and myself on Twitter. I'll put our Twitter handles back up. Will I? So here's our Twitter handles. I'm Wiggity Whitney. Matt's is cut off. There we go. And so follow Matt for the hot contents of what his daughter's taught.
Yes.
I can't see the comments now. Oh, okay. And I think we're saying, okay, we got some stuff.
Okay. So, yeah, Fool's wants to know if you erase the screen at each time, or if you.
Oh yeah, so code reuse is good. If that's infrastructure's code, that doesn't change.
Yeah.
And yeah, fill the screen again. Now, do you keep it? Oh, yeah, I have all. Fuel Sable says, do you keep the screens or do you wipe it in between? I actually just have a big pile of light boards. When
they're all disposable.
The whole main
Immutable light boards.
It's
immutable. immutable light board.
I think Deshaun's not around to answer my question, but that's okay. I think we're gonna wrap up and say goodbye. Hold on.
This was really fun.
Super fun. Sorry, to get back to where we were. All right. This is the end. I'm gonna screenshot this, Matt, and use it as the thumbnail. So that's why we need to be looking at the screen and smiling. All right, goodbye. Thank you so much. And everyone have a wonderful, wonderful rest of your Thursday. Bye.
Thanks so much. Super fun.